someone I know so much, and I trust her to bring in our A game. All right. So very quickly, today's topic we'll be looking at building efficient data modeling in Power BI for telecom industries. Now, while we decided to carve out like a niche for it, everything that you need to know about data modeling, how to approach it, everything that you need to know will be covered. I'm sure will be covered in this section. Please, can you just confirm that we can hear me? Probably drop a chat in the comment section that you can hear me, or use an emoji or a sticker to just indicate that you can hear me, so I know I'm not alone. All right, thank you so much. Thank you, Godwin, and good life. You can drop your hand now. Thank you. All right, so okay, Chinenye, please, you can drop your hand if. All right, thank you so much. So just to confirm that we can hear me and we can proceed while others join us. So while still on it, please, you can still keep sharing the links. You can share it on your status. You can share it on any community that is with the permission of the admin of the community to share, and then let's come together and learn. Okay. So I'll be introducing our guest to us. As much as she may not like to blow her trumpet, I will try to amplify it very well and try to blow it, if possible, blow it out of proportion, if it is allowed, if there's any word like that. But there's no how I will try to describe our speaker and I will blow anything out of proportion, because she's an amazing person. I don't want to start reading through profile. Let me just tell you directly from my heart. She's an amazing person. I've known her for a couple of times, and she has passion. She has a lot of passion for the community. She has a lot of passion for data community generally. She's a team lead, a community manager for several data community. Most pronounced one that comes to mind on the goal is Data Community Africa, that have been doing amazingly well in the data community space. They've been doing a lot of things in the data community, and she happens to be one of the team lead for the community. She's also a team lead for the Power Platform Lagos State. She's also a community. She's just an amazing person, right? She's been on several platforms. She's also a tutor. She has taught more than 2,000 person. And of course, I'm a product of our Power BI class, and a few other person here will be a product of our Power BI class, which something you don't want to miss out on. So Tina, I don't know if you can hear me. I'm trying not to over amplify. At the same time, I'm trying to also stay humble, if I can try to do that, but I'm not able to do that. Okay, I'm sure you can hear me, right?
Yes,
So
I can hear you clearly.
All right, so I would like to give you the floor now. I don't want to talk too much. I would like to give you the floor now, and then probably share your screen, and then, or you can put on your camera and we can put a face to the name, if that makes sense. How does that sound?
Unfortunately, yeah, that sounds really great. Unfortunately, right? And I'm not one to do this because I did not foresee this one coming, right? I'd prepared to, turn on my camera, smile a lot, so you can see my pretty face. But Nigerian NEPA had other plans. So my light just went off like a couple of minutes ago. And unfortunately, I'm also going to be using one screen to actually make my presentation. So it might be a little bit tacky, but you guys should just pardon me. I don't know. Maybe face is still visible in the next I don't know how clear this is, but yeah, guys, I'm so sorry. But aside from that, I'm excited to be here. Thank you very much. Please confirm you can hear me. I'm not sure if you can hear me.
Yes, I can hear you.
Okay, thank
Perfectly
you.
well.
Yes, we can hear you. You can
All
hear.
right.
You are audible.
All right. Thank you. So first thing first, I'm super excited to be here. Community is what I love. And thank you to all the community leads of this user group for inviting me for to come and speak to everyone about Power BI. And I'm definitely sure that we're going to have a great time. It's going to be practical. We're going to do a lot of talking, and then we're going to do a lot of hands-on as well. But trust me, we're going to have a great time together. And we're going to learn about data modeling. And just like Gabriel already mentioned, regardless of the fact that I want to talk to you about telco industry, this is also going to suffice for whatever industry that you're going to be working with, or the knowledge is going to be handful for whatever industry you want to, data that you're going to be working with. So without wasting much time, I'm just going to go straight into it. First thing first, for the benefit of those that might just be hearing the name Tina Okonkwo for the very first time, I'd just like to give a little bit background about myself. I'm a Microsoft Certified Data Analyst. Currently, I'm a Technical Community Manager at JADA, where we are sort of spearheading AI and data talents globally. Also, I'm a community manager at Data Community Africa, where I help beginners transition seamlessly into the field of data and sort of provide some sort of mentorship for the community. I also have 3 years of experience working across several industries. I've worked in retail, beauty and health. I've also worked in sports and entertainment, e-commerce, and a couple more though. And for like a couple more industries that I've actually freelanced in. Also, I train people. I think Gabriel mentioned that I took my Power BI class one time. I take courses on Power BI, data visualization, and storytelling with data. One of my goals is actually the top of my goal is to actually help beginners kickstart their career into data analytics. And this I do by speaking at events, mentoring people, organizing free classes, hosting events on my YouTube channel as well. And if you want to connect to me on social media, it's Rita_Tina on Twitter and Instagram. And then on LinkedIn, it's Tina Okonkwo. All right, let's dive straight into it. Our agenda for today, by the way, just like I mentioned earlier, we're going to go through I like to walk through the slides before we do practical and hands-on. So you just understand some key concepts and you understand all the things I'm mentioning when I start talking about it. But first thing first, let's talk about the telecommunication industry. When you hear telco, we're talking about the telecommunication industry. And if you don't know what telecommunication is all about, we're talking about, I'm very sure if you're Nigerians, you're familiar with your MTN, Airtel, Etisalat, and all these mobile companies that you get your mobile data from, you make calls and all that. Those are what we call your telecommunication industry. And today we want to focus on how to actually optimize their model, building telco, working with telco data, for example, exactly. So first thing first, what are some of the challenges that you see in telecommunications analytics? There's a large volume of data that is actually very different. What do I mean? What kind of data do you see them collecting from telco industry? You see data like, when you make calls, this data is being collected. The mobile plans that you do, this data is being collected, billings and all this, the data is being collected, and it's actually in a very large format. And this data, they're coming from multiple sources, right? They're coming from different sources. There are some in ERP systems, when you're collecting customer conversations, customer calls and all that, and so many other places. And there's a need to actually even centralize this particular data, right? And there's also the need because stakeholders would want to see like real-time insights, historical analysis. They want to see what is going on, network performance and all that. And there's the need to see all this. And without a good data model, they wouldn't be able to see that. Now, why do you actually even need that data model? The need for a data model, right? Because you want to stop if this data is very large and you want to stop you don't want redundant data, you don't want inconsistent data, so you would want to build a proper data model. And then if you don't have a good data model, you just realize there are a lot of complex relationship and then reports are slowing down in the organization. So a lot of complex relationships and reports are actually slowing down. So you want to stop all these things, and that is why you need to actually build a good data model. But what exactly is a data model, or what exactly is data modeling? Now, when we talk about data modeling, one very real life example will be this. Like when you have, we all have different sets of clothing, right? Like you have your shirts, trouser, ties, socks, and everything. Now imagine a situation where you have all these things, but they are in one location, like in one, maybe one, you just throw everything inside your wardrobe without organizing it. What happens is that whenever you need probably a socks, you spend a lot of time looking for socks, because you would have to remove your shirts, suits, traditional wears and everything before you can get to where probably that socks is, right? But now think of a scenario where you are organizing your clothing into where you have like your shoes in one place, your socks one place, your suits one place, traditional attires one place, church wear. You just arrange this into different compartments. Now when you need a socks or you need a tie, you can actually go to the location where you have actually thrown in that tie and pick it immediately. What happens? It saves time for you. The time you will end up scattering all of that, you would have just picked it up. It saves time for you, and you are much more organized. And this is very, very similar to what data modeling is all about. So data modeling is just you organizing and structuring your data based on relationships in a way that supports efficient analysis and reporting in Power BI. What this means is that you are just organizing your data based on related columns. You're looking at this column and this column. Oh, they look alike, or they are related. Let's group them together. And when we're doing this, we are organizing our tables into two different kind of tables: our fact tables and a dimensional table. So we're organizing it into two tables. So whenever you hear data modeling, you're just basically splitting one large table into fact table and dimensional table. Now, there are cases when you have like a large table will call something will call when your table is actually in a wide format, right? You have your table in a wide format. There's the need to actually break this table down into smaller bits, like to sort of normalize this table. And that is why we're organizing it into our fact table and our dimension table. Now let's look at what a fact table is. Now when we talk about a fact table, your fact table stores measurable transactional data. This is where your main business event is recorded, and it can contain several repetitive value. Now, let me give you an example you can relate to. Remember, I said, yeah, we're focusing on telecommunications, but I want to make sure that you can also relate this to, other industry and other areas of your analytics. Now, let me give an instance here. For example, everybody is familiar with a supermarket, or we've probably at one point in time been to a supermarket where we pick things off the shelf, go to the counter, drop that in, and the cashier or the sales rep takes into account all the information, all the things you bought, maybe the quantity of products that you bought, the enter the biscuit name, or anything that you actually bought, right? They are taking into account all these things. Now, that is what you call all these things that she's collecting is what goes into your fact table, right? Meaning you can come even next month, you do the same thing, you throw it into that fact table. Now, your dimension table contains descriptive attributes, meaning, like when we say descriptive attribute, mean it describes what is in your fact table. For example, your customer name or your product name. Now, that customer goes to supermarket and buy and comes several times to buy a product. In fact, one customer can come and buy the same product even multiple times, or other customers can come and buy that same product over multiple times, meaning what is reoccurring, right? But in your dimension table now, it just contains like the unique names of whoever has bought from you. For example, like that each customer that has come. So customer A comes to buy a product, you have a record of customer A information, like their name, phone number, email address, information about the customer, just saying. Or you can also have another table that contains like information about your products, your product name, category, subcategory, and things like that. So those ones contains what information about your product. So that is what your dimension table, or these are examples of your dimension table. They just contain descriptive attributes about your fact table. Why your fact table contains what? They store measurable and transactional data. Your fact table is transactional and is most likely numerical based, while your dimension table is largely text based. And one of the major differences is that your fact table is repetitive, while your dimension table contains only unique values. Now let's look at some of the types of data model that would end up with. Now, when you finally build your model, there are certain kinds of models you end up with, and two different ones: a star schema and a snowflake schema. Now, let me explain what a star schema is. Now, star schema is a type of dimensional model in which your data is organized into a central fact table surrounded by a number of dimensional tables. So for your fact table, it is organized into a central fact table surrounded by a number of dimensional tables. Now, what this means is that, okay, I think I can turn on my camera at this point. I'm sure everyone can see my face now. All right, let's continue.
Thank you, Nigerian.
Don't worry. I know they were going to bring it immediately. Don't worry. We are the special people. We are the special people in Nigeria on one day. So sorry for that break in transmission. I'm just going to continue. So actually, a star schema is that one where I've explained what a fact table is and what a dimensional table is. Now, scenarios where you have your fact table in the middle, surrounded by multiple dimensional table, that is what we call your star schema. So you have your one fact table or multiple fact tables surrounded by several dimensional tables. That is what your star schema is. And I think the reason why it's called a star schema is because your model is just shaped in the form of a star. Now let's look at snowflake schema. Now we'll talk about snowflake schema. Think of it as this: your dimension table has been further broken down into several other dimension tables. Now you have your star schema. Your snowflake schema is a combination of your star schema with your dimension models further broken down into smaller dimension tables. Take a look at this image on my screen, and you pay attention to, just follow my trackpad, and if pay attention to what is here, and here. So this table, and this table. What you can see is a star schema. But what's going on now is that this dimensional table has been broken down into 1, 2, 3. So this is now what we call a snowflake schema. So when you're building your data model, you either end up with a star schema or a snowflake schema. Now let's talk about something that's actually also very, very important when it comes to building your data model. And what we're talking about right now is relationships and cardinality. Now relationships actually define how your tables are linked. You can have your one-to-many, many-to-many, and one-to-one. And I'm going to explain what this is about. Now when we talk about one-to-many, this is actually the most common and the most preferred. Now, one-to-many is saying that you have one customer, or one customer can have many call records. So what this means is that, for example, now when you register your MTN line or your Glo line or your whatever network provider you're using, when you register that line, there's like a database that contains like your name, maybe your address, NIN, and other information about you. But now, as you've registered, you've started using that SIM card. Every day you make a call. This call is taken, it's being recorded somewhere. So you have and you make that call probably every day. You don't register your SIM every day. You register it only once, and it's once in that database, but you make calls every day. So these many calls that you've made, when you connect these two tables together, when a relationship is made between that particular database that contains your information and another database that contains call records, what we call that is a one-to-many relationship. Okay, so that is a one-to-many relationship. Then we also have your many-to-many relationship. Now, many-to-many relationship is not advice. Sometimes it's important to just create what we call a bridge table, where you're taking a unique occurrence of what is in both tables to be able to connect to them. Now, what this means is that, or an example would be when you as a customer, now you're on multiple plans, right? Probably you are a prepaid, or you have prepaid and postpaid sort of this thing, and then you and that particular plan has your name too. again. So you have 2 times on that particular table and 2 times on that. So it's just saying many occurrence of you here and many occurrence of you in another table. Then there's also the one-to-one relationship, which is not really common. So something I need to mention here is that one-to-many is also the same thing as many-to-one, okay? So one-to-one is where you have, like, there's one occurrence of that particular value here and one occurrence in another table. Something I need to mention to you is when you are doing relationship or when you're building relationships, you need to think of cardinality, because cardinality impacts your model efficiency. What does this mean? When you have high cardinality, a situation of high cardinality is where you are, for example, let me give you an instance here, where you are using, you have like different call records, right? You have call records here and you have maybe call records in another table. Now you are going to have a lot of call records. Now, instead of connecting call records ID to call records ID, what will be best to connect is customer ID to customer ID, because you would have lesser unique values, right? Lesser unique values. Your customer ID can be like 20, where you have your customer record ID being like 1 million. So if you use more unique values, it's going to reduce or slow down the performance. But when you use fewer, when you connect with fewer unique values, it makes your queries run really faster. So now that we've looked at this, something I want you to think of before we go into the hands-on part is there's some critical principle of efficient data modeling. And number one is you keeping your model clean and easy to understand. I'll tell you why this is also very very important. And the reason is because we want, oh, I think maybe my pace is, I'm going at a little bit too fast. I'm so sorry. I want us to practice. That's why I'm actually taking up this. My slides is very, very much available for everyone to read through, right? When we're doing the practical aspect, it's going to be a little bit, my pace is going to be a little bit slower, but I'm just going to quickly glance through the slides so that we can go into the practical aspect. Now, some of the things, but I'm going to take it a little bit slower now. Some of the things that I want you to pay attention to is, like I mentioned, simplicity. You want to keep the model clean and easy to understand. I'm going to give you an example here, or even use my a story or something that happened to me in the past, where I joined an organization and I asked for their data, or I wanted to look through their data, or they were working with them through their data, or the person that had left, actually, I was looking through their data models and it was chaotic. I couldn't understand anything that was going on in that data model. Like, it was really chaotic. Now, this is very, very bad and poor practice, right? You want to make the work easy for anybody that is going to actually be using that report to be able to understand how each tables are connected and what they've done. So you want to keep your model as clean and as easy to understand. Another thing is scalability. You want to make sure that whatever model you are building can handle growing data, because data will keep coming, right? The organization is going to keep generating data. So you want to make sure that your model can actually handle this data. And another thing you also need to think of, which is even the most important, performance. Key stakeholders don't have all the time. If I go to your report and it keeps loading for a long time, there's a problem. I'm just going to leave and I will not see, you will not be helpful for me. And you don't want a situation where you build reports and people are not using your reports. So you want to put performance at the back of your mind, right? Where you're optimizing your report for quick queries and fast visuals. Also, it needs to be very flexible, right? Allow room for future analysis needs as well. So let's go straight into our hands-on. And for this practical, we're going to make it very interactive. So it's going to be as slow as possible. I've already shared the resources with the community lead, and I'm sure it's going to pass that across to everyone. We are going to be building a data model using telco data. So we're going to do 2 aspects here, first of all. Now, the first aspect of our practical is going to be focused on just a simple data, right? And then I'm going to show you a very large data that I've actually taking time to actually go through the steps by myself and do that, and then would practicalize translating that into Power BI. How do we do this? Now, these are the steps to building a data model, and we're going to go through all these steps one after the other. So I'm going to stop sharing my screen here, and I would reshare so that I can walk you through the steps. Please, any question at this point in time before we actually proceed? Do I have any questions from anybody? I know I was a little bit fast, so let me just take.
Tina, there is a
Yeah.
question here. I think
Okay.
somebody wants to know the reason why when you're using a snowflake schema, you still have to break the dimension table into smaller units again. So the question is, what's the reason for breaking it down in snowflake schema? So I think the person just wants to understand the whole
Concept
essence.
of that.
And just
Okay.
before you answer, please, just before you answer. So guys,
Okay.
the link to these resources, the data and everything is on the comment section. So you can click on it, and if you want to follow along, which I would advise that you just listen and then watch. We'll make the video available and then you can watch. And but the link to the drive has been provided in. Okay, that's the question number one. You can answer question number one.
Okay.
Then there's another question.
Sorry, I don't know if I remember again.
Okay, the
Okay,
question
the
is,
need to break down your
why
snowflake.
do
Okay, good.
why is
Yeah.
the
So now here's the thing, right? There are cases when you want to build a like some persons want a very normalized. The idea of what we are doing is we'll call it like you are doing like normalization, right? Where you are breaking like one large table into smaller bits. Now, regardless of the fact that you have broken this down into smaller bits, you might want to break them down again or break it into the smallest possible bits. Now, that is why some people go as far as building a snowflake schema. But in the grand scheme of things, right? Building a star schema is like the most preferable when you want a good data model, right? So it's always advisable to use like your star schema, where you have like when we start talking about best practices for optimizing your model, having a star schema is the best route to actually follow. But when you want to denormalize, where you have smaller tables, that is when you go the snowflakes route. I don't know if that answers your question.
Okay, the second question is, what should I consider when building a scalable data model?
Beautiful. That is actually a very fantastic question. Now, there are some scenarios where your organization, if it's a very small organization, for example, right, you might be collecting data monthly or generating data probably yearly or depending on or even daily, right? Let's even use, for example, like a small store that sells maybe things like provisions and everything. They would have like a daily record of their sales and everything, right? Now, in this particular case where you're collecting this kind of amount of data daily, meaning you're going to be getting data every day. Now, you want to build a scalable data model in the sense that you want this particular model to be able to accept new data that will be coming in. So what you're thinking of is this: whatever data you are bringing into your Power BI, you're probably storing them in a centralized location, like probably a folder or some database where you're bringing in, or where you want to bring in this data from, right? So that way it's actually automated. You don't want a situation whereby for every new data that comes, you want to go back, bring it in and start building a data model from scratch. So those are some of the things you want to consider or you want to think of when you're building a scalable data model. I hope that also answers your question. So I don't think I see any other one. I'm
No,
just going
no,
to
no,
go
no,
ahead
go ahead.
and share my screen. Uh, just give me a second, guys. Okay, just give me a second, guys, because I want to still be able to see the comments. I'm just going to connect to my second screen. Okay, in case you catch me looking up, I'm just trying to look at my second screen as well. All right. Okay. Now, so I have this sample telco data. You would find that in the You'd actually find this in the documents. I'm also going to stop sharing my video for now so we can focus on the practical aspect. I've shared that in the drive. I'm sure you would have been able to see that particular word. So like I mentioned, this part of the session, we're going to take it pretty slow so I can carry everyone along. But I know we don't have a lot of time. I think I have, but I think we should be able to cover up in an hour time. So let's quickly dive right into it. So I have this particular data here, and this data, this is just a data in a wide format. Now, when we talk about wide format, we're talking about data that has like it's just it has a lot of columns. Let me even put it like that, right? And we want to normalize this particular table into smaller tables. Remember, I said data modeling is just you splitting that one large table into smaller tables. Now, this is a simple data, like it's very small, and I want to use this for practical. They are even larger. If you look at the second data we're going to be looking at, right, it has about 65 columns. Now, there are cases when you can have up to even 200 columns. And imagine loading that kind of data into Power BI. Trust me, it's going to take a lot of time for your visuals to load, which is part of the reason why we are building a data model. So the very first thing you want to do is to click on, so when building a data model, I like to do the framework in an Excel spreadsheet or on a piece of paper, right? Before going to Power BI to do the main thing. So I'm going to teach you how to do that here in Power BI, right? So the first thing you want to do is copy your column names. So I'm not going to do a Control-C here, okay? Click on this, and I'm going to paste all those column names that I've copied on here. So I just want to make sure we can see everything. Now, this is a sample data for a telco industry. I mean, it's way beyond this. Like when you see our exact data, you're going to understand what I mean. Now, the very first step in our slide says that we should separate our reporting fields into categories and values. Now, what does this mean? I'm going to explain to you what category data is and what value data is. Now, when you think of categorical data, think of it as data that are descriptive, data that describes something. For example, the name of a person, the name of a person, the name of a product. Those are categorical data. Now, when you think of value data, think of data that you can measure, things that you can measure, things that you can aggregate, value variables. Those are value variables. Now, an example could be like the price of a product, quantity of a product. Those are examples of value variable. Now, and the first step in building your data model is to separate your reporting fields into categories and values. And let's do that together. So here's what we're going to do. Now, looking at this data that we've copied here, I want to ask a question based on my explanation of categorical data and value data. Billing ID. What do we call billing ID? Billing ID is like your probably the billing identification number of that particular bill, right? What do you think it is? Do you think it's a categorical data or a value data? Please, this is going to be very interactive. Like we're teaching each other at this point because I want to learn as well. That is why I'm here. What do you think? Value, categorical. So let's do this. So if you don't have to type long thing. Let's do C or V. So if you think it's categorical, type C. If you think is value, type V. So let me see. Some person says C, some person says V. Interesting. Now I'm going to do my explanation of categorical and value variable again, so we understand what is going on here, because I want to make sure everyone is carried along and understand what we're trying to do. Now, when I talk about categorical data, it's descriptive. It tells you it's sort of something that is descriptive. Let me even give an instance here. My name is telling me, Tina is saying that is the name of Tina. It's describing who I am or what my name is, right? Now, when we talk about value variable is what? It's saying like measure, think of things that you can aggregate. I can sum up the quantity of products people buy from me. I can sum up the number of my followers. I can sum up the number of persons that are on this call, right? That is what your value variable is. Now, there are some, let me give you some something here. Now, somebody would think that because of its number, so it's supposed to be a value variable. No. Now, your NIN or your passport number, those can come in like number formats, but those are descriptive value because it's telling what the identity of you, or your identification number, or your passport number, the number on your passport. Like, so it identifies you, uniquely identifies you. So those are actually categorical data. So based on this, my explanation, do you still think billing ID is a value variable? Because billing ID is actually describing the identification number of that particular billing. So this is actually a categorical variable. So if you said C, clap for yourself, you're actually correct. Customer ID, what do we think? Is it a categorical variable or a value variable? What do we think? Is it a categorical variable or a value variable? So just C or V, let me know. Okay, I see a lot of C's. Oh, that means we are on the same page. So C it is then. First name, what do you think? First name, is it a C or a V? Is a C. Beautiful. All right. Last name, C or V. I think is also very self-explanatory. C. City. Is it a C or a V? Let me explain again, because somebody just asked an interesting question. By value variable, do you mean numerical data? No, I don't mean numerical data. I mean data that is measurable data. Now, what do I mean? Because there are some numerical data that are not measurable, or that you can't aggregate. So don't think of it as numerical data. If you think of this as numerical data, you would naturally assume that every numerical data should be a V. So let's do this. City is also a categorical. If you agree with me, region is the same thing. Now, age group, what do we think? Is it categorical or value? Categorical or value? I mean, if you look at age very well, it can be a V, it can be a C. Now, what do I mean? In the case of when it's an age group, I think it's a category, right? You can already tell that age group is categorical. But when it is age, I mean, you can get the average age of people in a class, right? So that way it is what? Value. But in this particular case, this is actually categorical. I hope you all understand this. So C. Plan ID is also a C. Plan name is also a C. Monthly fee, what do we think? Is it a C or a V? V. I see V, so V. That means we understand what's going on here. Now, billing dates, what do we think? Is it a categorical variable or a value variable? What do we think? Categorical. That means people are very solid and you understand what is going on here. You understand what is going on here. Now, while I was preparing for this class, let me tell you something interesting that I thought of. Now, billing dates, I think in some cases, it can also be like some sort of value. Now, what I mean is sort of value. For example, I'm trying to see the difference between two dates, right? Let's say I have like a start date and an end date something, and I'm trying to see, okay, let me use the instance of even our telco data. You know, when you make a call, for example, you can make a call and it's recorded in like time and days, right? Like date time formats. Now, and the telco industry will want to check like the duration that you spent on that call. So it will be the difference of when you started making that call to the difference of when that call ended, right? So in some cases like that is also a V. But in this case, I'm going to leave it as a C. Now, why I always like to put my data as C, another reason is because I want a star schema, and I don't want to I want a star schema, or and I don't want to be able to break it down into smaller bits. So sometimes I like to leave it as C. So in some cases, I'll leave it as a V, but depending on what kind of data that I'm actually currently working on. But just so you have that at the back of your mind. Now, the next step, we've successfully completed the first step, which is what? To split our data into what? Facts and categories and values. And the next thing is to consider all value fields as our fact table fields. Remember, what we are trying to do here is to sort of build a fact table, right? We're trying to build a fact table field. So what we're going to do in this particular case is this. So I'm going to go to my Excel spreadsheet. So all my value variables, I'm just going to create, what we're doing is fact and dimension. So all my value variable, I'll throw them in this fact table bucket, which is, so I'm going to just put my monthly fee here. So I'm just going to make this bold. Good. So this is my facts table, right? They say consider all value variables as your facts table. Now, the next step is that we should look for hierarchies within the categories. Now, let me explain what hierarchies are. Let me explain what hierarchies are. Now, hierarchies is just you looking for relationship. Oh, I see a question. What's the distinctive difference between value variable and numerical data then? I mean, a categorical data can only be counted and it doesn't matter how it appears. On the other hand, both value and numerical can be involved in mathematical operation, and yet you said they are not the same. Now, let me explain. Your phone number, is it numerical, or I would like you to answer that question. Your phone number, is it numerical or text? Is your phone number numerical or text? Jamil, I would like you to quickly answer that question if you are still on the call. Is your phone number numerical or text?
Yes, thank you very much. My phone number appears as numerical, but it is actually a categorical data because we can't actually perform any mathematical operation on it.
So does that answer your question?
No, it doesn't.
No, it doesn't. Okay, beautiful. Now let me explain. What's the distinctive difference between value variable and numerical data? Now, all numerical data are not value variable, right? Now, what this means is that there are some data that come in the format of numbers. For example, your phone number that is numerical, but you cannot aggregate your phone number, because if I add my phone number and your phone number together, it will not be like, you cannot aggregate it. So I can't call it a value variable. Do you understand? So I can't call it a value variable. It's actually a categorical data. If I have a data that contains probably the name, phone number, address of this thing, that particular phone number that is there cannot be a numerical variable, because I cannot be a value variable because I cannot aggregate on it. Another example can be your postal code. Postal code comes in the format of numbers. It is numerical, but you can't aggregate it. So it's not. So any numerical column you cannot aggregate is not a value variable. I hope this answers your question.
Okay, ma. If I understand you well, because usually I do categorize data as just numerical and categorical data. It doesn't matter. So, example of like NIN and phone number now, they appear as digits, but
Yes.
you can't do anything on them mathematically, which means I just categorize them as categorical data. So now what you are saying is that whenever a data appears as a number like NIN and phone number, they are what? They are value, right? They are
no, they are
really
categorical.
Okay. All right.
That means
Thank
you might be getting me wrongly, or I don't know if I'm not saying it correctly. I say when you have those kind of data, they are numerical, but they are actually categorical data. They are not value variable. Are we saying the same thing here?
All right, I get it. Thank you.
Okay. All right. So the next step says that we should look for relationships within the categories. Now, when we're talking about relationships between these categories, we're talking about like looking for similarities between them. For example, if you use the instance of like a family tree where you have like grandfather, father, and child, there are similarities between all of them. And that is what we're going to try to do in this particular place, to look at similarities between the data that we actually have, or this data that we're actually splitting into our facts table and our dimension table. Now, if you look at the first one, which is billing ID, I don't see, I think the only similarity that you have between billing ID is probably your billing dates. But because I'm going for a star schema format, I'll just take it. I don't see any similarities between this particular column and any column. If we move to the next one, which is customer ID, if I look at my customer ID, my first name and last name, I see a similarity, because if I know my customer ID, I'll be able to know the first name and the last name. and maybe even the city that that customer is in, and also the region, right? You can also even know the age group that that customer belongs to. So in this particular case, customer ID, first name, last name, city, region, and age group can stay in one dimension table, so they are related. And then what I'm just going to do is I would copy this and I would come here and I'm just going to paste it over here. The next one is my plan ID. And if I look at my plan ID and my plan name, they look very, very similar, okay? They look very, very similar. So I'm going to come here and I will, or they have relationship, and I'm going to put plan ID and plan name. Now, the last one is my billing date, which I would just assume has no relationship with any other column here. And if I go to my next step on my slide, it says every categorical field without hierarchy, I should consider it as my fact table field. And B says each category of hierarchy, I should consider it as dimension tables, right? So consider all categorical fields without hierarchy as fact table fields, and each category of hierarchy as my dimension table. So if I come here, what I'm going to do is I'll just call this one my dim customer. And I'll call this one my dim plan. Now, what's the next? And then we need to copy all the ones without hierarchy. So I'll copy this and paste. I'm also going to copy this and paste this. Now, the next step in building our data model says that we should identify the smallest unit within each dimension as a primary key. So how I like to look at this is just consider something that when you know that one, you'll be able to find the others, right? When you know that one, you'll be able to find the others. Consider that as your primary key. Then what we're going to do is we'll go back to that spreadsheet that we're working on. The smallest unit in my dim, so we are looking at our dimensions, remember, dimensions, that's where you're considering the smallest unit. The smallest unit in this table is our customer ID, because if I know my customer ID here, I'll be able to know every other thing here. If I know the city, I might not be able to know the customer ID, because one customer ID can belong in different cities, or 5 customer can belong in one particular city rather. So you want to look at the smallest possible distance. And remember, your primary key must be unique. So that is why we're going with what? Our customer ID as our primary key. And in here, very, very self-explanatory and very visible that the primary key here is our plan ID. So what your primary key is just the smallest units in your data, right? Think of the smallest unique units in your data. For example, you have like your NIN as a representation or as a unique identifier of you in a country like Nigeria. No two persons can have the same NIN. Now, the next step or the last step in building your data model says that you should replicate all primary key fields in the fact table. So replicate all primary key fields in the fact table. So what you're going to do is this. You're going to replicate all primary key fields. So I'm going to come here, copy this customer ID, paste here, copy the plan ID, and I'll paste that here. And the reason why we're doing this is because we want a connector, and our connector is when you find your primary key in another table, it becomes your foreign key. So, and when you're doing your connection, you connect primary key to foreign key. So we're going to call this customer ID our foreign key, and this one our foreign key. Now, this is an example of a data model. What you just need to do now is take this plan, right? You know, as an architect, they build like the plan of a building, and you know, they just take that plan and give it to like the contractors or the people that are going to be building the house. So that is what we've just done here. We've built a plan, and all we need to do is take this plan to Power BI and practicalize. And I mean, we can do that, right? We still have I think we have like 30 minutes left or thereabout. So I'm going to take this one that we've done here and just let's even do a do a sample of what we've just done here in Power BI. Take this particular distance and take it to Power BI and let you see how we can actually do that. So what we need to do is this. I'm going to go to my Power BI. I already have my Power BI open here, and I'm just going to get my data. I'm just going to get my data, and I'm going to bring it in from my Excel workbook. Okay, I think it's a text and CSV file. So it's a text and CSV file. So I'm selecting my text and CSV, and I would click on the data here and bring that in. Okay, and the next thing I want to do here is click on transform data to open up my Power Query editor. Good. Now we have the same data over here, right? But we don't have our data model. So we want to build that framework we did in Excel. We want to bring it, translate it onto here. Now what we want to do is I'm going to duplicate this particular sheet because the idea is that at the end of the day, you want to end up with these three tables, your facts table and your two-dimensional table. So I'll just duplicate this twice. So I'll right click and duplicate, okay? Right click again, and I will duplicate. By the way, the data we're working with earlier is the sample telco data. That is what we're working with earlier. So the next thing I'm going to do is I'm just going to rename this. So I'll call this one my facts. And then I'll call this one my dim customer. And then the last one, I'm going to call it my dim plan. By the way, I'm saying dimension, this thing, plan dimensional table. But if you look at all these tables, we still have all our original files. We want to be able to, the only thing we want to see in our plan, dim plan is what? Just the plan name and plan ID. You can go ahead and start removing all the columns one by one, but that will take the entire time. So what you want to do is to click on your choose columns, go to choose columns and just select only the columns you need. So when you click on that, this is going to pop up. And then what you need to do is uncheck the box that says select all columns and just select plan ID and plan name, and you click on OK. Now, the next thing you want to do, because if you look at this, it contains several repetitive values. But what we are trying to do is to create a master table or a dimensional table of our plan, right? Which is like a master table of plan information. So what we want to do in this place is click on the plan, okay? That's the primary key. Click on the primary key, right click and do what? Remove duplicates. The next thing you want to do is go to your customer and do the same thing. On our customer table, what do we need to do? So when we go to choose columns, the only thing I want to see in my customer table is the customer ID, first name, last name, city, region, and age group. And I'm going to click on OK. And same thing I did for my dimensional plan. I would right click, I'll go to my primary key, which is this customer ID. I'm going to right click on it, okay? And then do what? I would remove duplicates. And then the next thing I want to do is go to my facts table. On my fact table, what should I have left? I'm going to have what? If I go to choose columns, remember you can always go back to the spreadsheet and check the information there, right? So I would unselect this, and on my fact table, what I have there is billing ID, customer ID. I'm also going to have my monthly fee and the billing dates. And then I'm going to click on OK. Okay, and also the plan ID. Yeah, plan ID. And I'll click on OK. Now, quick one. Do you think we're going to remove the remove duplicates from here? Anybody wants to help us with that? Do you think we're going to remove duplicates from there?
We always have to remove duplicates.
Okay, now let me mention something. Before you start building your data model, let me mention that, you have to clean your data. And cleaning your data requires you removing duplicates, changing data types, and all of that. I mean, we didn't do that because I didn't want to focus this class on data cleaning or whatnot, right? That's why we just went straight into building our data model directly. So, but when you finish cleaning your data and you start building your data model, on your fact table, remember I mentioned something, your fact table can contain several repetitive values. So there is actually no need to remove duplicates, because if I come here now on my billing ID and remove duplicate, or come to my customer ID and remove duplicates, I will end up losing data. Because why is this? A customer can come multiple times to do the same plan, or on different days to do the same plan, right? Meaning that customer ID will appear multiple times. So you don't want to do that. You just want to remove duplicates only on your dimension table. And after doing this, what you need to do is to just click on your close and apply. And when you close and apply, your data is going to load into your Power BI. I'm just going to wait for that to load.
While that is loading, can I ask a question?
Yes, please.
Why don't we have a primary key for the fact table?
Interesting. Very good question. Now, here's the thing, right? On your fact table, there's some sort of primary key, by the way, because sometimes you'd have like your record, right? Like of something probably happening, like in this case, our billing ID. That might be a fact table. That might be like your primary key in that table. But most times, your fact table only contains foreign key. Your fact table only contains foreign key, and this is because your fact table contains several repetitive values. Let me take you back to the example I gave. Now you're going to a supermarket, and maybe every day you go there, you buy a product. Tomorrow you go, for every day of the week, you go there and you buy a product. But this particular supermarket that you're going to every day, they have a particular database where they have your information, like your name, your location, maybe your phone number, your date of birth, and just information, your email address, just information about you. Right? But every day you keep coming like to buy this, and every day you come and buy this, maybe they have like some sort of order ID that they took, order dates, the product you bought, the product ID, and some other information like that, right? Now, what this means is that you as a customer, you appear how many times on that table? You appear several times on that particular master table that they are creating every regularly, right? And if your customer ID is in that particular table, is a foreign key. You probably have product ID in that table, which is also going to be a foreign key. So what your fact table contains is several foreign keys. I hope that answers your question.
Yeah, that makes sense. Thank you.
All right. So now the next thing we're going to do is to go to your model view. Okay. Now, when you go to your model view, if you are like me that likes to leave their auto model checked up, Power BI will automatically do that connection for you. But if you have that unchecked, you would probably need to start connecting this by just dragging the column. For example, if I delete this connection, okay, by just right click, I want to delete and show you how you can connect. And I just bring in this plan ID and I drop it on plan ID. So it's going to bring up a pop-up that says I'm connecting this table to this table, okay? And if you look at the cardinality, you can see something that says one to many, which is the example I gave you while we're walking through the slide. Like you have one occurrence of this and many occurrence of this. Like you can even see here that you have lots of twos here and just 1, 2 in this particular place. There's also something called your cross filter direction. Now, when we talk about cross filter direction, you're saying, I want you to go, if you say single, you're saying, I want you to go to this table and filter for me. When you're saying both, they're actually two, single and both. When you're saying both, you're saying, I want you to go both ways and filter for me. Like you can come filter from this table, I can come and filter from your own table as well. Now, then you have this active relationship icon, always make sure this is turned on, except you have like multiple many-to-many relationships. That is where you can leave this unchecked, and you are using what we call the use relationship DAX function, right, to actually make or activate a relationship. But if you don't have this checked, when you're trying to do your analysis, it cannot detect the next table that you're trying to get information from. So you always have to make sure that your make this relationship button is turned on. That is what this is, right? Assume referential integrity is for when you are working with direct query on like direct query mode, when you're trying to import data into your Power BI, which you would likely like on fewer occurrences. Probably that is when you're going to be working with that. The next thing you just want to do is click on save. And you have that connection. And this one and this star here is what is showing you that this is a one-to-many direction. Now, this arrow that is pointing one side is showing you that this is a single filter direction. If it was two, you know that it's a bidirectional, both it's filtering in both ways. Okay, so this is an example of how to build a data model. You have that plan where you are splitting your data into categories and values, and you have another way where you are loading it into your Power BI and trying to do that there. So I don't think we have a lot of time, but I want to just show you an example of a telco data. I mean, I wanted to use this small table so that it's not very confusing and you're very familiar with what exactly data modeling is all about before I walk you through this thing. Maybe this might even be a take home and this thing. I mean, I've done the hard work, but you can just see an example here. By the way, I generated this data by myself with the help of Python and just to use as practical aspects for this question. And I made sure that I just sufficed all the columns you would probably have in a telecommunication database. Now, what this data contains is, number one, you have your customer ID, right? Okay, maybe we should look through the dictionary so that way we'll be able to see what I'm talking about here. Now, this is the dictionary here, right? And it contains like just different information about like like your telco data. And in your telco data, you would have like your customer information, subscription type, plans, different plans, right? Subscription plan, the cost of the plan, your data allowance, like in terms of MB, gigabytes, and all that, the number of call minutes that you've had, number of SMS, the current status of your subscription, length of calls that you make, right? Call start time and end time, so many other different information that are important to your telco industry. You also have like a network coverage area, tower status, and all of that to be able to check if a tower is actually on or is actually active or inactive, right? So you have all these informations, and then you are now tasked with building a data model. Now, this particular data has 65 columns. That is what you have here. If I bring in this data into Power BI directly and I start loading visuals, like it's going to be very heavy on it. And that's why we try to split it into smaller tables, right? And over here, I've already done the idea of doing this into our facts and our dimensional categories and values. And I think on sheet 2, yes, I've actually tried to do this into like a fact table and a dimensional table. And if you look at here, because I know this question might even come up, like what if you have multiple fact tables? Yeah, now there are scenarios where you have multiple fact tables. Now if you look at this, because when you're working with very large data, I mean, which is what I wanted this to actually suffice for. And this is what you would see in the real world scenario. If you are working as an analyst in the telco industry, you'll probably be familiar with this, where you have like lots of fact table, because what is your facts table? It contains repetitive value. I have call records. People make call all the time. I have SMS record. People make send messages all the time. There's also data usage that contains like, okay, how your data is living and how your data, like, or data updates. Today is 27 MB. Tomorrow it has reduced to 21 MB, that kind of thing. There's also the billing, right? That whenever you buy a data or you purchase airtime, is recording is recording all that, right? Every subscription you do, whether you are your subscription is active or it is not, things like that. Then network faults, all those times that you know, MTN internet is down or Airtel internet is down, it's being recorded. How long was it down for? The kind of fault, was it that a pole fell down somewhere or they disconnected something? How soon was it resolved? Has it been resolved? Is this have they not resolved it? Those are some of the things, some of the kind of data that you probably did, and these ones are reoccurring because every time, if you agree with me, like MTN internet is always down. So every time the internet is down, all these are being recorded. So they're repetitive and they go into what we call your facts table. Then there are dimensional tables that contains like information about customers, right? You have information about customers. You have like the plans of those customer. You have like subscriptions that those customer that we subscribe to. Like, there's a master table of all the plans that you can subscribe to on MTN. Then you probably have like a dates dimension table, which is very, very important, especially if you want to take away all the auto dates hierarchy. We're going to talk about that because I still have my slides to go. I'm sorry, it looks like I'm rushing, but I'm trying to meet up with time so that we can also take a lot of questions as well. Then we also have like towers, right? That contains like the name of the tower. MTN or Airtel, all this telecommunication industry, they have different towers in different locations that covers a certain amount of area, right? You get information, or they keep the information of when it was installed and things like that. You'd have data like this, and it's now left for you to, you know, build a data model, probably out of all of this, right? Now you want to connect your customer ID to all the dimension tables that you probably have here. You want to connect your plans as well, your plan ID to where you have your plan ID. You want to connect your subscriptions as well to, you know, tables that you probably need. So all these things are very, like, it's very, very important if you want to make sure that you have an optimized model. Because if I'm taking this long table into my Power BI might likely be suffering, especially when you start having hundreds of millions and billions of rows of data and you start working with that. Because yes, data is always going to increase, okay? So you need to pay at this thing. I'm going to let you play around with that data or play around with it since I've already given like access to it. You can feel free to actually reach out to me for questions and everything. I'll also be talking to your community lead to see. So let's quickly talk about like some of the best practices. Now, there are cases when in an organization, your data or your key stakeholder or your manager is telling you that, okay, they want to just see reports on maybe people in Abuja or people in Lagos. Now, and you're going to that database, where that database is or where that data is, your data is not limited to people in Lagos and people in this, and it's left for you to query that data and make sure that you are limiting your data load. Like, you're just querying the data for people in Abuja or people in Lagos as requested before bringing it into your Power BI. And like I mentioned earlier on, star schema is very, very preferable to use when you're doing all of all this. So you have your central fact, no matter how many fact tables you have, surrounded by what? Your dimensional tables. Then you want to make use of aggregated tables. Like, for example, there are some things that you can actually aggregate. Maybe they are telling you that they want to see the total sales that we made in this for each customer. Now, instead of you bringing like customer name and customer, maybe they're telling you want to see the total sales made by each customer in a particular location, you can write a script for that in your server, in your database or wherever you are bringing that data from, to aggregate that, do that calculation before bringing in that data into your Power BI to now display, right? So leverage it is very important. It would help optimize performance of your report. Also, disabling the auto date time is also very important. Now, if you have several dates in your table or in your data set, you want to make sure that you are going to, if you go to options and settings on Power BI, you would see how to disable auto date and time. You just need to uncheck the box, because if you have these several dates and time in your model, it's going to create underlying dates model for you, like underlying data. You're just going to see a lot of hierarchies there. And what this means is it starts slowing down your report. So it's advisable to create a centralized date table that you can connect all your other dates to and use that. Create a centralized date table, mark it as your date table. So Power BI knows that that particular date table is the date table that you want to use for your analysis. Also, you want to make sure that you are defining relationships clearly, making use of your one-to-many, considering one-to-many in most times, right? You want to make sure that you're using one-to-many when you are defining these relationships. Another thing is to use DAX measures for calculation. Now, I tell people that it's very important to minimize the number of calculated columns that you want to do. Anything you can create in your Power Query editor, create that before loading that data into Power BI. That way, you are able to minimize the use of calculated columns and you just write a lot of measures instead. So use measures instead of calculated columns, because calculated columns have the capability to increase the size of your data model, and that is not what we are aiming for. Also, you want to implement what we call incremental refresh for large data sets. Now, I'll let you read more about incremental refresh, but what this is just talking about is you archiving past data, right? Archiving past data, and just sometimes there's some data, for example, MTN has been in existence for more than, I don't know how long, but I mean, you'd assume that MTN has been in existence for a very long time, and they might not be able to, they might, key stakeholders might just want to see what has been happening just in the past 10 years or maybe even past 2 years, probably, right? So you don't want to go and be bringing data from 15 years ago. You want to just streamline it to that particular period of years that they want to see the data. So that's why you are archiving past data and implementing incremental refresh. That way your report loads really, really fast. I hope that I've been able to explain data modeling to an extent, and I've been able to by now you're familiar with like the telco industry, how to even best practices when you're building your data model. You understand what facts and dimension tables are, and you can even follow the steps to build a data model and build your own data model. Follow any industry, it's the same framework, any industry you're working with. But I hope I've been able to explain this to a great extent. I'd like to thank you all for listening to me, and thank you to the leaders for having me. And at this point, I want to spend the remaining time I have, 14 minutes, to take questions. So if there are any questions for me, please, I would love to take them now.
All right. Hello, Tina.
Yes, I can hear you. Can you hear me?
Yes, we can hear you. I personally can hear you.
Okay, sort of waiting for the,
Are you
I don't know
with
if
us,
there are
ma'am?
questions. Yes, I'm with you. Can you hear me?
Yes.
Okay, I don't think I don't think Gabriel is still on here, but I'm just going to take questions.
I am.
Oh, okay. Okay. I think I see one question already. Somebody says, how can you use a star schema with multiple fact table and multiple dimension table? I want you to listen to the definition of what a star schema is. What do you think a star schema is? A star schema is where you have your fact tables surrounded by what? Dimensional tables. So it's just you connecting fact tables to dimension tables. As long as your dimension tables are not further broken down into smaller dimension tables, what you're working with is a star schema. Now, where you have your snowflake schema is where you have your dimension tables further broken down into smaller dimension tables. That is where you start talking about your snowflake schema. I don't know if this answers your question, but yeah, that is it. I think some answer up or thereabouts. We can take them. Chidima, I see Chidima's hand up, and there's somebody called guest 09. Okay, let's take Chidima first. Hello. Chidima, where were you?
Hello. Can you hear me? Am I audible?
Yes, I can. Yes, you are audible. Please go on.
All right. Thank you so much for the class. Like, I learned a lot. But while you were doing the facts and dimensions table, I noticed
Yeah.
that I noticed that there were no unique what will I call it? Is it unique column that's in for the three tables you created? I expected like you were supposed to have like a primary key that will form a relationship between the three tables. So I didn't see that because when you created the other table, that is the dimension plan, had just like two columns. The second one had like I don't know how many columns they had, but I didn't see the primary key in the three tables. So how were you able to form a relationship between the three tables? That's my question. Thank you.
All right, very good question. So first thing first, right? When you're connecting your tables, you're connecting dimension tables to fact tables. So you're connecting primary keys to foreign keys, and your foreign key is in your fact table. Now, you don't necessarily have to have the same key in all three columns, because what you're interested in is your fact table and your dimension tables. For example, in our DIM plan, we had plan ID. In our deemed customer, we add customer ID. And in our fact table, we add both customer ID and plan ID. And that is how we're able to connect it. So plan ID to plan ID on the fact table, customer ID to customer ID on the fact table. And that is why when we're creating this thing on Excel, I mentioned something that the reason why we're doing this is because you need something to be able to connect to something. So something from your dimension table to be able to connect to something from your fact table. I don't know if this answers your question, Chidima. But yeah, that is the
Yes, it's
explanation.
like a star schema. So yes,
Yes.
the fact table is connecting to the dimensions table. Okay,
Yeah.
thank you so much.
All right, let's take the next person. I don't know who's next. Moderator, can you help me here? I think guest 09 is next.
Guest 09, please unmute your mic and ask your question.
Okay, my question is, you have the dimension table in Power BI. Is it possible to update the records when there are changes?
Interesting. And thank you for asking that actually. So probably because of time and everything, we just quickly went into it. But if I add this data, and when you're working if you're trying to do something like this in an organization, there are certain questions you want to ask. Oh, how frequently does your data get updated? How frequently is your reporting? Are you people interested in real time? Like, do you want to make sure that this report is refreshing every minute or every hour? These are questions you want to be asking. This will guide your direction in building a data model for the organization. In this case, we just went direct, like we assume that, this is a one-time thing, right? But in other cases, if I had a spreadsheet like this, or if an organization was giving me a spreadsheet like this, and they're telling me that, along the line, we're going to be getting more data and everything. So, and we don't want to be calling you every time to come and build our data model. What I would have just done is this. I would upload this particular table or this spreadsheet that we uploaded to Power BI in a folder. And I will pick this data. Now, when I'm connecting to Power BI, instead of connecting to Excel, I'll connect to a folder. On Power BI, you will see when you want to get data, you can get data from a folder. So I'll get data from that folder. And what will happen is after building my data model, if I keep updating that folder, automatically my data model keeps updating. So that is the best route, or that is one way that would help you support like future data. I hope that answers your question.
Yes, thank you.
All right. Adekunle Tosin, we'll take you.
Hello, ma'am.
Yes, I'm with you.
Hello.
Yes, I can hear you.
Very much. Thank you very much. Thanks for the opportunity. I sincerely want to ask if the recording will be made available, because I believe I missed the earlier part where we were doing the stuff on the Excel sheet. So I would love to go through it one more time. Then I can drop my question with the team lead, which I believe they are looking forward to. So that's my question.
All right.
So, yeah, please go on. I think that's
okay.
That's for you.
So if you check the chat, you would notice that that already stated that the link will be posted, the video will be uploaded on YouTube, and then the link will be posted. So don't worry, we'll try to post it between today and tomorrow. The link to the YouTube would have uploaded it on YouTube, and then you can go there and rewatch it. We don't want to be sending drive. We want to have a place where everybody can just access, and that makes sense.
Yeah, it makes sense. That's master
right.
data
Okay.
management. Makes sense.
All right. Okay.
Okay, I don't know if we have any more questions.
Okay, I think there are two. Please, Adekunle, you can drop your hand. There's another Ade here. I think I can see your hand up. Please.
Yes, thank you.
Okay.
Can you hear me?
Yes, we can.
Yeah.
All right, thank you so much, Tina. I joined for the second half of the webinar. I found it highly informative. Having worked in the telecoms industry, it was great seeing how you analyzed everything. I have a question, though. I'm not sure if you touched on it earlier. How were you able to generate the data using Python?
Oh, interesting. Okay, so we're talking about Power BI. Yeah, I didn't think that maybe I should have left that part of the conversation out too well. But yeah,
Right.
I mean, it's not okay, thank you. I think Gabriel already answered the question. So I used Faker, but you would have to be familiar with Python to be able to generate there are a couple of scripts that you would have to write and all that. And if you want, I mean, ChatGPT is there, by the way. I actually use ChatGPT to generate the scripts. So I love AI so much. Like, I'm a big fan of AI. So I'm one of those persons that I say we are lucky to be in a generation of, where AI is. So I sort of use ChatGPT to generate the scripts that generated the data for me. So a couple of ChatGPT plus, no, not ChatGPT, sorry, Gemini plus or ChatGPT plus Gemini plus Google Colab, right? And if you want the scripts for how I generated it, I would be happy to share that with your community lead.
All right. So
Thank
when
you
it comes,
so much. I appreciate that. You mentioned Faker. What's Faker?
Oh, Faker is actually the Python library used for generating the data.
Right.
Okay.
So like a mix of ChatGPT, Gemini,
Python
Faker, and Google Colab, right?
So Faker is just the library, right? It's a Python. I wrote a Python script. Right? Thank you very much. Yeah, similar to Pandas. So when you do like your imports Pandas as PD, there's also an import Faker.
Right. Okay. Why Faker over Pandas?
So you need Pandas to read your CSV. Faker is the library that actually generates or does the randomization to generate the data.
Right.
Mm-hmm.
Okay. All right. Thank you so much.
Okay, and to add to that, just in case you're not familiar with Python, you can actually, with proper prompting, you should be able to generate a little bit of data on ChatGPT. You can just interact and prompt it very well. Just that if you are using some version of ChatGPT, especially, it's going to tell you that it's not able to generate the data for you in a downloadable CSV file. So it gives you the Python script instead. But there are some instances where if you're using a paid version, you ask it to generate it and ask it to make it downloadable in a CSV format.
It's CSV file. Okay.
Yeah, CSV file. So it's help you generate the data in the CSV file. And when you're not satisfied, you go through it, you can ask it to update, make some setting correction and update it.
Changes.
Just proper prompting and you will generate the data.
And to also add to that, there is Data Mockstar on ChatGPT as well. You can use that to generate data. That one is for data generation.
My boss don't speak.
What did you call it? Data Mockstar? Could you spell the Mockstar?
Yes. Let me just Mockstar, MOCK STAR.
Right.
Okay, Data Mockstar by Adam Miko.
That's correct.
Oh, okay. Wow, fantastic. Thank you so much.
All right, thank you. I'm not sure there's any other question. I think we'll have to let Tina go. Like I looked at her schedule today and I was wowed that she still had time to of course, commitment. She had told us that she was already going to be available. If not, if she had all the options and alternative to just say, okay, today let me just rest, she would have rested and all of that. But then, thank you so much, Tina. I want to believe this was a very enjoyable section, right? We did enjoy ourselves. If you agree with me, please just give her a virtual clap. Please just give her a virtual clap, telling her thank you. And of course, at the end of this call, you could give an excerpt of what you've learned on your social media platform. Just so you know, Tina is also like the chief advocate of building in public. I was surprised she didn't even branch there today. She didn't even say anything across that line today. But she's a very she's the chief advocate of building in public. If you have been in the data space, you would hear her always shout building in public, and building in public. So with that said, you could want to just give your excerpt on what you've learned on either your LinkedIn page or your Twitter page. You can tag us at Abuja. I think on Twitter is Abuja PUG, and then on LinkedIn is Abuja Power BI User Group. You can tag Tina as well, and then of course we want to tag her and appreciate her for the time she has spent with us today. Now, if you have any further question as time goes on, please let us know. Now, that said and done, this is the second month, and we are hoping to also do this again in March. It's a monthly meetup series, and every last Saturday of the month we are going to be having this meetup, and the goal is to just equip us in Power BI and see that we grow. So let me quickly check my date, and I can't actually remember top of my head. Okay, the last Saturday in the month of March would be on the 29th of March. So on the 29th of March, we would be doing this again. Yes, E. Hello.
Hi, good evening. Thank you very much.
Good
Yeah,
evening.
can you hear me?
Yes, I can hear you.
Can you hear me now?
Yes, I can hear you. I
Yes.
can hear you.
Oh, okay, good evening. Thank you very much. I want to say a very big thank you to Tina. She did a very good work, and really glad I was there. Okay, so apparently from what you just said, this meeting was organized by the Abuja branch, right?
Is that by the Abuja Power BI User Group? Yes.
Oh, okay. I don't know. I saw the link on the data group in Lagos, so I don't know if sending the recording, I'll be able to get it
Okay.
since I'm not on that group.
Okay. So what we'll try to do is, Sid, I think what we'll try to do is we'll also upload the link to the YouTube page on our